Welcome to episode 212 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how's it going today?
I'm okay, Rob. How are you doing?
It's the last week of summer here in North Carolina. My kids are going back to school next week.
And that kids around here started like 2 weeks ago, or a week and a half ago.
Really, that early? I always thought North Carolina was early compared to New Jersey, at least.
I think our schools are just underfunded, and it's just trying to get in the days where they can or something. I don't know.
Oh, man. Well, I was going to say my kids have chosen to spend their last few days of summer freedom with stomach bugs. So they're both sick today, unfortunately.
That's the wrong time of year for that.
Yeah, I guess there must be something going around. But hopefully they'll get over it soon and be able to go to school next week.
You didn't take them to a sketchy restaurant last night or anything, did you?
No, I don't think so. I don't think it's food poisoning. I think it's just a stomach bug.
Yeah, I met someone. I saw someone once, good friend, who was like, "Oh yeah, I just had food poisoning last night, but I'm better today." Large group of us hanging out together. The next day, we all had food poisoning. Yeah, 24-hour stomach bug. It was absolutely terrible. It was, well, anyhow, it's completely unrelated though.
Okay, well, at the top of our episode, I'd like to read a piece of feedback. We got a tweet from Adi Shavit, who we've had on the show before, and he's the one who runs the Core C++ conference. And he wrote, me running, listening to the latest CppCast, where Rob and Jason are discussing the Dropbox article about dropping C++ as a common shared mobile dev language, in parentheses for wrong reasons. And then he said, my brain, the salami method. And Rob and Jason, the salami method, which we incorrectly referred to as the burrito method.
Yeah, that was totally me, yeah. It's definitely not the burrito method.
Definitely not the burrito method. And we do have this article from his blog where he talks all about the salami method. And I think we talked about it before on the show, and I'll make sure
at least once.
The show notes. At least once. And we probably talked about it with him when we had him on.
I think that's what happened. I think we mentioned the article, and then we talked about it with him later. Yeah, I'm pretty sure. And that's 2 years ago that he posted that article, so we're getting old.
Yeah, we are. Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us again today is Vittorio Romeo. Vittorio has been a software engineer at Bloomberg for more than 3 years, working on mission-critical company C++ infrastructure and providing modern C++ training to hundreds of fellow employees. He began programming around the age of 8 and quickly became a C++ enthusiast. Vittorio created several open-source C++ libraries and games, published many video courses and tutorials, and actively participates in the ISO C++ standardization process. He's an active member of the C++ community and is an ardent desire to share his knowledge and learn from others. When he's not writing code, Vittorio enjoys weightlifting and fitness-related activities, competitive challenging computer gaming, and sci-fi movies and TV series. Vittorio, welcome back to the show.
Thank you, Rob. Hi, Rob. Hi, Jason. It's been a while. I think a bunch of years since I came here.
Yeah, I was just checking. You were like episode 7 we had you on.
Wow, was beta testing the CppCast. Now it's grown quite a bit, and I'm really happy to be back here. Thank you, guys.
You mentioned sci-fi, and I feel like a lot of us in the programming world enjoy sci-fi. And I had a recent class where I'm like, I always ask my students, tell me your hobbies and stuff, because I want to see if I can relate C++ and what we're talking about back to the things that they do for fun. And I had no one in like a class of 15 mention sci-fi at all. And I'm like, are you for real?
No. That's surprising.
And then one other person was finally like, oh, well, yeah, actually, I watch sci-fi all the time, but I don't consider that a hobby. That's just a thing that I do in my spare time. And I'm like...
That's the definition of a hobby.
It kind of sounds like a hobby to me, but I don't know. So
maybe it's just normal, like it's a requirement. They don't see it as an extra thing.
Perhaps. Well, I'm just now that we went through all that, I'm curious, is there anything good you're watching right now?
Not right now, honestly. I have a list of things that I watched in the past that I really loved, like Fringe, for example, was a really good TV show. And also an anime called Shinsekai Yori, which I found on Stephen Lawaway's website, which is, it has a bunch of reviews for sci-fi movies and stuff like that. And on my website, I actually have a list of like shows I watched and I liked. And To be honest, I have done a very poor job at keeping it updated, but I should go there and add a bunch of the new stuff I've seen, which I think is worth sharing. But right now, not much sci-fi, unfortunately. Mostly watching series that are quite popular, like House of Cards and House of Paper and stuff like that. So I need to get back on track with my sci-fi passion, honestly.
But, to be fair, though, when I look back and look at how many hours of sci-fi I've watched, it's questionable how I have spent my life. So there's that part. If you're out doing things instead, that might be a better use of time.
That's true.
Yeah,
Although I will
can
say,
do both.
You can.
you can definitely do both. If you're looking for a newer sci-fi series, I watched The Expanse, which is now on Amazon Prime Video, and that one was quite good.
Okay.
I feel like there's a reason why I haven't started that.
Yeah, it's
I've seen
it involves, we've expanded into settlements on like Mars and in the asteroid belt, and it was a good show.
Is it complete? Like it's over?
There have, I think, been 3 seasons, and I believe they're working on a 4th.
Okay.
Yeah.
An Amazon original series or something?
I think it started on Sci-Fi, and then Amazon picked it up for the 3rd season.
I have seen
good reviews.
Yeah, it's got good reviews.
Some people complain that once Amazon or Netflix picks up a series, you really don't know what's going to happen. Like they might cancel it for seemingly no reason at all because they're not driven by the same ratings and ad revenue kind of things that the major networks are.
Yeah, I mean, I think the show and the Amazon season of the show was still good. Yeah.
Okay.
Anyway, back to the main topic of the podcast. We got a couple news articles to discuss, Vittorio. Please feel free to comment any of these. Then we'll start talking more about what you've been up to lately, okay?
Sure, sounds good.
Okay, so this first one is on the Visual C++ blog, and it's C++ cross-platform development with 2019 version 16.3, VC package, CMake configuration, remote headers, and WSL. And it's just a summary of some of the improvements that went into the latest version, covering some of those things I just mentioned. Now they're able to do parallel builds with WSL and in Linux, which I thought was pretty good. Yeah.
Yeah, my mind is just a little blown by this all around because I didn't realize, first of all, that you could connect to the WSL instance with Visual Studio, which is the obvious
thing. That is fairly
to do.
new. Yeah.
Okay.
And that was just added with 2019 16.1, it says.
Okay, yeah, so that's not that long ago. And then being able to use VC package. So you can build one project in Visual Studio. And the way this is written, basically be like, I want to build in Linux. I'm going to use the WSL. I want to build in Windows. Okay. It's all just right there, all in one IDE. I feel like I have to give it a chance at some point.
Yeah, and they're talking about some of the CMake integration with VC package. So when you're, writing out your CMake, you can write find package OpenCV, and if it knows you don't have OpenCV yet, it'll prompt you to go and grab it with VC package, it looks like.
I feel like this level of integration should also work with the way that I use CMake. Mm-hmm. And that's something else to test and see how well it all works. CMake. We're talking about CMake here. I meant Conan. It would be interesting to see how Conan does also integrate with WSL and stuff, which I'd have never tried.
Yeah. Anything else specific you wanted to call out here?
I don't really use Windows much for development, and if I do, I'm kind of stuck with MinGW and MSys2. They kind of do the job quite well. I'm really happy to see the direction Microsoft is going with WSL and bridging together the world of Windows and Linux and giving people more options. And what I can say about Visual Studio is that I've used it in the past for C# developments, and it's just an amazing tool, so convenient to use.
Yeah.
So nice to be able to to have that interactive debugging and stuff like that. And if it gets very, very nice integration with both CMake and WSL, I can probably see myself trying it out again in the future if I can keep my Unix-like workflow all the way through. That would be really nice.
It looks like they're definitely heading down that path where they would be able to support that. Yeah.
I'll sometimes have students ask me like, well, how do you, use GDB in this really difficult debugging situation? And I'd be like, well, I've already told you that all my projects are cross-platform. So if I have a really hard debugging problem, I just open it up in Visual Studio and use that debugger.
Yeah. Okay, and then the next article we have is this from Arthur O'Dwyer's blog, and it's covering the post-Cologne mailing. And it's first going over a couple items that were in the post-Cologne that he identified, some of which he worked on, like adding more implicit moves, which look like they're going to be making it into C++20, right?
Yeah.
Yep.
And then he also... we talked to Arthur earlier this year, and he's very opinionated about not being a huge fan of the 3-year release cycle, and he does spend a bit of this blog post kind of reiterating that, hoping for like a 5-year release cycle, but I don't think that's going to change anytime soon. Yeah.
I got hung up on the features and didn't even get down to the question about the release stuff, because this one, more implicit moves.
Sure.
Like, oh, and by the way, there's more implicit moves. And you're like, no, wait, what? Like, I have to make some notes real quick because I need to change a couple of conference talks that I'm giving in a week, to cover these possibilities. Like, I didn't see that coming. And I still don't know the full implications of it because, as he says, there's no prior art for it. So clearly no compilers implement it currently. And
he did say that's the case with some of them, but with some of the implicit moves that he was first recommending, he says some compilers were already kind of doing this under the covers, right?
Yeah, and for the sake of our listeners, this is throwing an R-value reference.
And not just that, also returning an R-value reference.
I think, but returning an R-value reference, that's what's new, right? That's the thing that he says there's no prior art for. Because,
yes.
Okay.
Are you saying that some compilers used to move when throwing, even if it
yeah, that's what he's saying here.
Okay.
Oh, no, sorry, not move when throwing. It was move when throwing value, not move when throwing an R-value reference. That's the prior art part, yeah. And now the surprising part is if it's an R-value reference and you return that, then that's an implicit move.
Yeah.
And I really want to know, what does that mean if it's an R-value reference structured binding, which is an R-value reference into a temporary thing that was hidden object. I mean, like, is that an implicit move or not? An R-value reference from a sub-member of a structured binding. Return.
My mental model for a structured binding is that the names you provide in the square brackets are like aliases for the existing things. They're not really references, even though they act like them. So
yes, but if I explicitly said auto ampersand, and then gave the structured binding.
But then that would, like, the reference would be the object that you're destructuring, not the actual names.
Yes.
So you would say, if you return one of the pieces, are you expecting to be moved? Is that what you're saying?
That's what I am asking, yes.
Okay. Yeah, that's interesting. We should see what the wording says. But...
Yes, I'm going to have to go and read the wording, and I'm going to have to figure it out. Usually this kind of thing I like to just test and see what the compiler does and call it good enough.
But you know what happens when you do that? GCC and Clang are going to do something different, and then you're going to have to see the warning again.
Well, yeah, but usually GCC and Clang agree on that kind of thing. Usually. Usually, most of the time.
Was there any other of the actual papers he's highlighting that either of you wanted to talk more about?
I want to say the implicit move from R-value reference, in my opinion, is really, really important. This has been something that when I teach classes at Bloomberg and also, in general, when I'm telling people about R-values, they get really surprised when you have an R-value reference and it becomes a copy when you return it. Because mentally, it's an R-value reference, it's something you could consume. So why isn't the return consuming the actual thing? So I think this will make teaching R-values a little bit simpler, as it removes this kind of edge case which you need to explain to people why it doesn't move. That's nice. Regarding the other things, I see that Arthur is I'm not sure if the right word, but maybe conservative in the sense that he has some really good points about potential dangers of proposals that were accepted. or not. For example, there's the polymorphic allocator one and the NTTPs one, which is basically allowing things like strings as template arguments. Right. There are some cases and, situations where they don't work in a very, I would say, not in a perfect way. However, there's a risk here on both sides, right? There's something that Bjarne always says during committee meetings, which is basically perfect is the enemy of good. Mm-hmm. We need to be able, to move forward and give people what they want. An example of a very good use case of NTTPs is Hanna Dusikova's compile time rejects. That would not be possible without the proposal was accepted. On the other hand, it's really hard to figure out where the line is, whether, it's good enough or it's good, but it puts us into a corner where we cannot fix some underlying issues later. So I think these papers need to be considered very, very carefully, but also, if it's just something which is a tiny problem or some edge case which is not likely to happen during real code, I would prefer not to see these features delayed, because right now, like today, there are libraries that could be using these features and be really, really powerful and good for the C++ ecosystem. So we need to be careful in both directions, in my opinion.
Right. If you don't mind, I'd like to go back to what you said about R-value reference implicit moves. You said that'll make teaching it easier, but I have to ask, at Bloomberg, or at least in the people that you teach, will they be able to use C++ 20 as soon as it is released?
The situation at Bloomberg is quite interesting in the sense that pretty much every team has a lot of independence in the way they decide to work. Okay. Not just regarding compiler versions, but even languages. Usually everybody tries to be, to conform to the same compilers and target the same architectures. We do have some legacy architectures that prevent us from moving to even C++ 11, so some teams are still stuck on 03, but most of the teams that just target Linux can basically decide whether to stay with the official compiler, which supports 14, or, experiment and just use latest version of GCC or another language or whatever. So there's definitely going to be some people that maybe don't have, safety critical systems that might jump onto C++ 20 as soon as it's out. I can definitely see that happening. And some people that will have to wait until it's been battle tested and until, there is official support for it. So it's more of a mixed scenario there, but I definitely believe some people will jump on it. And in general, what we try to do when training is also preparing people for the future. Our expectation is that eventually, even if it takes a long time, they are going to have exposure to these new technologies. And even if it's not inside Bloomberg, just as part of their daily contribution to the C++ community, or if they want to participate in standardization, it's good to have them know what's coming and how they should prepare themselves and what they can work for if they decide to participate in ISO and stuff like that. So I would definitely teach this in my classes with the caveat, obviously, that it's just in 20. But it's always, I'm very confident it's going to be very nice to hear for the students that all these weird edge cases are being worked on, that there is hope for the future. Okay. And, people know what they're doing, and we're trying to make the language easier to use and more consistent within itself. So that would also encourage people to stay with C++ and not say, oh man, I need to remember all these edge cases. Knowing that it's being worked on is a good thing.
Yeah, I appreciate that perspective because, I mean, sometimes I'm in classes and I'm teaching, it sounds like similar experience, where you have different teams and some of them can only use 11, some of them are up to 14, some of them are up to 17, and you're like, well, this is what you can do. You can't do this yet, and you can do that now, and yeah. So I see the point, though, of giving them hope for the future.
Yeah. Okay. So, Vittorio, we talked about a recent blog post you wrote just a few weeks ago about fixing C++ with epochs. Can we start off by going over that proposal in a little more detail?
Yeah, absolutely. So this started basically from a feature that the language Rust has, which is called editions. And the idea is that in Rust, they wanted to have some sort of way to perform backwards incompatible changes, but still allow people to use code from the past, like seamlessly with new code. And the way they did that is basically every module you write, so every source file you write, rather every library, has something called an edition, which right now can be either 2015, 2018. And between editions, the syntax of the language can change. For example, in 2015 edition, there was little to no syntax to represent a dynamically polymorphic object, which was a little bit, dangerous because you could start making these polymorphic objects in your code that's not really obvious to the reader where they are. And in 2018, they added something called DYN, the dyne keyword, which makes it obvious that the polymorphic object is dynamic, and they require it before a type name in 2018. So whoever is reading the code is immediately aware that there is some polymorphism there, which could be a performance hit, or even, just to know that it is an interface which you can extend on. And if you want to do this in a way that's backwards compatible without also breaking the previous code, the only way you could do this is basically saying, okay, I take this module from 2015, this module from 2018, I compile them to some sort of intermediate representation which is common between them, and then they can communicate. So basically what happens is that the compiler has support for all the epochs, and there are the called editions, and they compile to the same AST, and then these ASTs can obviously communicate together because they are the same intermediate representation. I think it's a very elegant way of fixing quirks in the language, and in general trying to make it safer by default without completely changing the way the language works, as the example of the DYN keyword shows. And my idea was basically, let's try to bring this to C++ and see how we could do it, see what we could fix, and if it's worth it, and what we have to say to the committee to convince them that the idea is worthwhile. So I basically wrote this blog post that has some diagrams that explain in a visual way what these epochs or editions would be for C++. And the idea is that we should leverage the new module system, which is going to be shipped soon, as it's basically a self-contained unit of code, and it will compile to some sort of binary representation that is, it will be independent from the syntax of the language. So there is pretty much nothing preventing us from saying, okay, this module is using the language version number 2, this module is using language version number 3, and we can change the meaning of the keywords and the syntax between versions while still retaining compatibility between the modules, as the intermediate representation, which is the binary format or the AST or whatever, is still the same. Ideas of things we could change range from completely insane, like making the language const by default and adding a mutable keyword to have mutable variables.
Oh, that's the sane recommendation, not the insane one.
I wish. I would love this, but the risk there is that when somebody is trying to read C++ code, now they have to have a switch in their brain, and they say, this is C++ with this epoch, and this is with this other epoch, and trying to read code which looks the same but is very different can be a problem.
Right.
The other thing is we could do things that make the language a little bit safer by default. They remove pitfalls that especially catch newcomers and don't give any problem to the experts, and make the code easier to read. As an example, one of my favorite things I would like to see from this is just prevent uninitialized variables without an explicit syntax. Like if you write int I semicolon, that should be a compile time error, because it's a source of bugs. Often people, especially newcomers, leave variables uninitialized by accident, and the program seems to work, and then they have to describe what undefined behavior is and so on. But if we have an explicit syntax like int I equals uninitialized or int I equals void, which I think is what D does, then the programmer has to consciously say, okay, in this code, I want this variable to be uninitialized. So it's just few extra keystrokes, but it forces you to think about whether you want it initialized or not, and it makes it obvious to the reader that they need to be careful while reviewing the code and make sure that the variable is always going to be initialized. So this is an example of something we could do. Another example that I think is very worthwhile is preventing implicit conversions. Like nowadays, you can simply say int I equals 3.5, right? It's going to compile, it's going to give you a warning, but it's usually a bug. Like you probably don't want a conversion. I would like to see the language move into a direction where you require a cast there. Like a cast is mandatory. So you need to be sure that a conversion is taking place, and whoever is the code also is fully aware that there is a potentially narrowing conversion there.
Right.
So all of these small tweaks, I think they don't change the way the language works. I think they don't spawn new dialects. I think they don't really force people to learn different epochs. They are just minor fixes that can actually make the code a lot safer, both for experts and newcomers. And this would bring new people to C++ because they see that we are making the language more friendly to beginners, and also prevent bugs that everybody makes. Like, I make these bugs. I make these mistakes. And, sometimes I just leave this variable initialized by accident once in a million, right? But I like not to have that not to happen. I like the compiler to tell me, what are you doing? Do you actually want this to be uninitialized, or did you make a mistake? So I think these things are entirely reasonable. What do you think?
I kind of like the idea.
Yeah.
I think it's doable. I think to all the people that say, oh, why don't you just break backward compatibility? I say, can I introduce you to my friend Python 3? Which I still run into people that are like, oh yeah, no, we just can't update our code from Python 2 to Python 3. We're still using Python 2. I'm like, that was like 18 years ago, right? Or whatever. I mean, it was a long time ago. It was before Vittorio was born, I'm pretty sure. Python 3 came out. And so we clearly can't just break the language, but if we just had some way, what is it like? I mean, there's some precedent for similar things besides Rust, like option explicit and like visual basic versions, right? I think that's right. Where at the top of the file, you would have to say like, you must declare variables, because in some languages, you don't have to declare a variable before you use it, that kind of thing. I think it's kind of a similar kind of idea. Maybe.
I've actually done some research. Like, I'm surprised. There are many languages that do something like this. There's useStrict in JavaScript. I think Perl has something similar. And even C#, like in the latest version, they basically finally realized that having nullable variables by default is probably not a smart idea. So now you can opt in at the beginning of your file, and you say, no, I want to be explicit about nullables. And you have to put the question mark after the type. So it's something that languages seem to be moving towards.
It's a per file basis.
Yeah, Rust is fairly new, but if you think about it, like, it seems very sound, and it has been working for them for 4 or 5 years. So it's fair to say, like, there is no multi-decades experience, but it's also fair to say that if you think about it from a technical point of view, it kind of makes sense, and you can see that there is a trend in languages to move towards this direction. And I think we really need it. Like, I don't want a Python 2.3 schism, or, another possibility would be completely changing the language with the same technique, like having an epoch that completely changes the language and makes it super nice. But still, then you're like making a new language, and you're forcing people to be able to switch back and forth, which, is not something impossible, but I'd rather keep C++ as a linear chronology of small changes that continuously make the language more refined and safer to use. And I think, honestly, if I can find a way to get the message across the committee, I am confident they would see the value in this and hopefully understand that there is no risk of creating dialects. There is a risk, like, if when we have the feature, obviously you can propose crazy stuff, but every single proposal would have to be treated like a proposal to the main language, right? We don't want to break language compatibility. We don't want to surprise users. So what we would do in an epoch would be something small, positive change, maybe a little bit more verbose code, but safer defaults. That's what I want. The counter argument would be, maybe this is not impactful enough to warrant a new feature like epochs. Mm-hmm. But I strongly believe that everybody makes mistakes, and also if we want C++ to survive, it has to be friendlier and safer for newcomers. Like, you can't expect newcomers to be able to know all the warning switches and all the quirks and stuff like that. Like, the code has to be more explicit, and unsafe code should be allowed, but it should be, marked with a big red sign that says, I actually know what I'm doing, right? I want this to be unsafe.
All right,
So go ahead, Jason.
I was going to say, if you could wave a magic wand right now, what would be the very first thing that you would do in the epoch? Like, pick one thing. What's the first thing?
It's a tough question.
Nope, and you only get one answer, just for the record.
Fine. I intuitively, I would immediately say implicit conversions. I think they are a source of bugs and incomprehension when reading the code more than uninitialized variables, especially when it's very subtle, like inside some if statement, you get a contextual conversion that is usually beneficial, but in a particular use case scenario, it actually makes your code do the wrong thing, and it's really hard to pinpoint what the problem is, because if you enable, W conversion, you're going to get it in a million places. So I would like to see implicit conversions go, or at least most of them, and just basically have explicit by default everywhere and force people to have casts. And this is especially important when you have code that's doing a lot of arithmetic or numerics, because it's really easy to introduce subtle bugs just by, having integer promotions happen or having narrowing conversions happen while you're doing some maths inside your expressions. It's hard to spot, and it's a source of mistakes. Just imagine like the ternary operator. Like if I swear, if I tell anybody, please tell me what the result of this ternary operator is, where there's a bunch of signed and unsigned types and stuff like that. It's really hard, right? That shouldn't be like that. It should be explicit in the code what the thing is going to be, and it should force you to decide what you should evaluate to. Like, you don't want to go through the wording in your head and trying to understand what a type would be. And maybe it doesn't matter for most of the code, but when you have some sort of a value that's important and you don't want it to be narrow, you don't want to lose information, or you don't want the sign to be wrong and stuff like that, and it's buried deep inside your program, you're going to be happy that you have to write those extra casts manually, even if they're longer, because they're going to save you hours of pain and suffering.
Mm-hmm.
So I wanted to back up a little bit and talk a little bit more about how this would work in practice. So if we pretend it's, 2023, C++23 is out, and we have this feature, and you have an application and you want to consume both like a C++20 epoch library and a 23 epoch library, that should just work seamlessly?
Yes. So my understanding, I'm not an expert on modules, so I want to say this as a disclaimer. With my understanding that I have, I think this is entirely possible on a technical side, but if someone comes along and says, wait, you are missing this detail about modules that will make this impossible, then sure. Now, assuming that my understanding is correct, which is basically, every compiler given a module will produce some sort of binary object which is independent from the C++ syntax. So it's basically binary AST representation or metadata, which contains all the information that's required to consume the module. Then in 23, you might imagine we have this new 23 epoch, and some modules will have it, some modules won't. However, when you compile them, they will all produce the same kind of AST language or binary language that contains the information required, and then you can simply link the modules together or consume a module's interface from the other, because all the information is the same. So this is my understanding, and this is my, how I predict it would work. Does that answer your question? Or
I think so.
Yeah.
I feel like it should absolutely be, my gut also says that it should be workable, assuming that none of these epochs change the layout of an object, or somehow affect calling conventions, basically.
So I think that there is a risk there. Like, I definitely don't want to touch anything related to library or ABI, at least in the first epochs.
Right.
What I would like to see is fixed language syntax. That's basically it. Let's start with that, see how it goes. It's very low risk. And if we see that this is the way forward, then maybe we can start thinking about things that are a little bit more risky, like, for example, create an alias for stdx that in a module, it automatically becomes stdy. So something that kind of converts a dangerous type to a non-dangerous one. But then you have the ABI implications, and you might introduce extra conversions. Another thing that I think is reasonable is, as an example, take std optional. I think that the default should be, when you use the star operator, it shouldn't be UB. You should throw if the value is not there, and then you should have something like unsafe get, so you can be explicit, and you can say, okay, I'm sure this thing has something inside it, and I want to grab it outside. So maybe what we could do is some sort of notation where you say, okay, this method is enabled from epoch A to epoch B, and is disabled from then onwards, and this method is only available from epoch B onwards. So kind of like fixing the interface of standard types without changing the layout, which wouldn't affect ABI as far as my understanding goes, but it would make the interface safer and easier to use.
It's an interesting one to mention because optional is by far not unique when it comes to that kind of UB, right? Like,
yes.
Would you also then make the checked interfaces the defaults around vector and shared pointer and unique pointer and that kind of thing as well?
I don't think it's a completely unreasonable train of thought. As I mentioned before, this is something that would come later and has to be considered very deeply because it has deep implications for the language.
Quite.
But I think there was like a survey recently, and, bugs caused by unchecked vector access were like the most common ones. I think it was actually a talk by the most common bugs at Facebook or something like that. And like the truth is that if you provide an interface which is unsafe by default and is the most convenient to use, then you're going to have a bad time, right? Those two things shouldn't match. It should be either convenient and safe or slightly less convenient and unsafe. So I believe that if C++ wants to compete with the newer languages that have a little bit of more sound underlying principles regarding interface design, like Rust, then maybe this direction might be worthwhile. And again, I don't want to come in the committee and say, hey, we have this new feature called Epochs. We need it, and we need it because we want to fix the language. I want to take it like a very gradual approach, sell the idea of epochs first, sell the very small but very beneficial changes like, as I mentioned, uninitialized variables, which I hope would be, not very controversial. I hope everybody can agree that uninitialized variables are often a source of bugs and they should be more explicit. And then, judging from how that goes, we can start thinking about, changing the way we do defaults, making them safer, making them more friendly to both newcomers and experts. And again, that needs to be done with a lot of thought and care. It's not something we can just jump into and say, okay, let's just fix the language completely, because that's not going to happen, and that would just kill the proposal.
It wouldn't, and it would get hung up in the committee, I think, for a decade trying to figure out what the first epoch should be if you tried to make it more
exactly
aggressive. Big.
Yeah. So since we're talking about the committee, you wrote this blog post a couple of weeks ago, and you are a committee member. I believe you went to Cologne, right?
I do go to meetings. I don't have, like my affiliation is with Bloomberg, so I go on behalf of the company. Yeah.
Right. So have you gotten much feedback? Do you plan on putting together an actual paper for a future meeting?
So I have not discussed this in Cologne. What I did was back in Jacksonville, which was, I think, last year, I did float this idea around in Evolution, but it was, just as a comment, reply to another comment. And the vibe I got for the room was very, very negative, in the sense that everybody was immediately saying, hey, you're going to create a lot of dialects. It's going to completely change the language. People are not going to know what kind of things they are writing. And what I tried to do with this blog post was answer those, I would say... Concerns, yes, those concerns. Because I think that if you do this in the incorrect way, you can definitely go into that direction, and we don't want to do that. But if you take this step by step, you do it properly, there is no risk of getting dialects and making the language impossible to understand. So they're fair concerns. I think there's a little bit of, extreme reactions, because you need to understand the tough principle behind those very small gradual changes before you can accept the idea of, changing the syntax. But hopefully I will write a paper for the next meeting,
Okay.
And I believe it would be something very simple, just showing the idea and just showing a few possible minor changes. And I think I will target Yugi, so it's EWGI, which is the incubator. And yeah, the incubator is usually more lenient and they give you a lot more feedback how now you can present this in a more convincing way to evolution. So I think having the first step, getting the initial feedback and, even just like friendly advice, something like, hey, if you change this paragraph to this and if you remove this bullet point, maybe you will get less concern in evolution because there are people that have been bitten by this in the past or stuff like that. Right. So something like this, I think, would be a great first step. Also, Jason, we can probably fix initializer list with this.
That's right. You were in that room when I gave that talk, weren't you?
Yes, I was there.
Yeah, yes. Well, more implicit moves, but not with initializer list. Anyhow. Yeah.
So you have gotten like some good feedback, and you're definitely going to pursue writing a paper for this. Good feedback from the blog.
I got overwhelming positive response. Like everybody, okay. I don't want to say everybody, but like the majority of people were like, "We definitely need this or something like this." Like I cannot envision C++ continuing in the future without a way of changing these very, very bad defaults and very, very bad syntaxes that lead people to make mistakes. So the sentiment is that people want something like this, which is really good to hear. I've also had some criticism, both constructive and non-constructive, let's put it this way. But a constructive one was also very valuable. And, the fact that Rust is not very, it's not very baked is a very important one. Like we need to be careful and see if this thing can scale in the future. And also the other feedback was, this can be abused. So it has to be very clear that the goal of this is not revolutionizing the way you write C++, but incrementally and linearly changing this. I believe there are some languages, even Rust does this in a way, like at the beginning of your file, you can have enable and disable features independently. So you can say maybe this file uses this particular syntax, but not this other one. I don't really want to go down that route because then you get into the problem that to understand what code you're reading, you have to keep in mind all those switches in your head. So what I want to do is basically have some linear, gradual polishing of the language. That's it. Like I don't want those kind of knobs. So all of this criticism was really, really useful. I might actually write a follow-up post because I have collected a lot of interesting things that are worth mentioning. So I might do that. Otherwise, I will capture them in the paper. So it's been a really great response, I think. And I'm happy to see that the community wants something like this, that I'm not crazy. And, I have hope for this. Let's see.
I'm curious because I think Bjarne has said that making this a pointer is a design flaw in the language, but he couldn't have made this a reference because he created this before references were added to the language. So I'm kind of curious what his specific take would be like. Tell you what, we can make an epoch, and this is now a reference. And see like how he responds to that.
I believe that Bjarne is very, very concerned about not splitting the community and not creating dialects.
Right.
So I think that this side of him would overpower the side where he realizes that the initial decision for this was a mistake. I wouldn't want to see, like I would agree with him, I wouldn't want to see two different source files and one says this arrow and then the other one says this dot.
Okay.
Because then it becomes really hard to teach. Like you're going to have to teach people, before it used to be a pointer, now it's a reference, but it's the same syntax. And then, just, I don't really like that.
Right.
If we did something a little bit different, like for example, ban this and add a self keyword, it might be better in a way because at least you're not changing the meaning of an existing keyword and creating this sort of, hey, mental switch is more like a new thing. However, I don't think this is like a very major problem. Like, I don't believe that this pointer is a source of bugs or inconvenience. It's just weird. But
it used to be.
Why did it used to be like?
There was actually. It's been long enough ago now. that GCC made it the default at some point in my recent memory to optimize around checks for this being null, because there used to be a bunch of old code that relied on being able to check to see if this was null, if they were actively operating on an active object. And when GCC made this the default, like Clang and everyone else had already been doing this. When GCC made it, I think it was made it the default, and it was a while ago now. It like caused this uproar because they're like, you broke my code. Like, no, your code was already broken. So yeah, it was a thing. It was a thing. Like old school C++ stuff had some really bad habits in it.
I see. I think I remember that. Actually, I think it was a few years ago. I do remember like there was a huge uproar about this.
Yeah.
I wouldn't say that though. This is like, I would say this is caused by the fact that this is a pointer, but it is still like completely broken code, like in the sense.
Oh yeah.
Like you cannot check if yourself is or no.
Yeah.
Like, it's not the same. Like this is like complete misunderstanding of how C++ works compared to leaving a variable initialized by mistake. Like that's my. It's not a very strong argument, but I think that there's a fundamental difference in these two bugs. It's like the first one is like you have no idea what you're doing, right? The second one is more like, yeah, you might have an idea what you're doing, but sometimes people make mistakes. So I think that for the first ones, we should probably think carefully about fixing those because, you know, it's not the common scenario.
Right. I agree. And I think checking if this is null is something today all compilers will warn on, even with warnings disabled.
Okay.
Because it's like, no.
So you're going to be at CppCon this year giving a talk. Do you want to tell us a little bit about what your talk will be?
Oh, yeah. So the other thing I've been involved into in regards to the standardization was this proposal called function ref. And basically imagine something like string view for functions. That's a very rough approximation. But the idea is, you know, I give you this function ref with a given signature, and then this thing can refer to any callable which matches the signature. And the benefit of our function, SCD function, is that it's super fast. If everything gets in line, it's exactly the same as a template parameter. So it's quite nice. It doesn't require templates, so you can use it in polymorphic interfaces without getting the cost of a CD function. And the other thing I really like is that it makes really clear from the signature that whoever is consuming this function is not going to store it. You know, it's just reading it, calling it, and then giving it back. So it makes it obvious as like a borrowed function. Sometimes with a CD function, you don't know when you get a constant CD function ref if that thing is going to be retained or not. Well, this one makes it obvious. Anyway, I have a talk on this at CppCon, which is going to be like an updated version of a talk I gave beforehand at a few other conferences. And I got a really good feedback at all the previous iterations of the talk. I'm going to incorporate it in CppCon. I'm going to try to make like the ultimate version of the talk. And also,
you're running out of time.
Oh yeah, I'll be good. So yeah.
It's 2 weeks.
If you're interested in the history of a proposal that started from a tweet from Eric Niebler, which said, this is a proposal to write itself. And then he went through like 6 iterations and it's still not in C++, then you should come to the talk. I think it's really educational to see how many very tricky edge cases and very tricky design decisions have had to be made.
Right.
And still not everybody is happy with this. But it was supposed to go into 20, just didn't go in because of a lack of time. So I'm very confident this will be in 23. The other thing I'm going to be doing at CppCon is a pre-conference class about C++ 11 and 14. Mm-hmm. And this is my first time giving a class, so I'm really excited. I've been doing this inside a company, inside my company, but never as a public trainer. So this is a new thing for me, and I hope it will go well. I really enjoy teaching. And what I'm basically going to do is give people that are very experienced with C++ 3 a very quick overview and up-to-speed course with C++ 11 and 14, all the language features and the most important library features. And there is going to be a very big focus on interactivity. So what I'm going to do is basically have the attendees convert a C++ 3 implementation of std vector to C++ 14. and see how you can use the new features to make the internals better, the API better, and even some non-orthodox things like adding map, reduce, and transform to the vector to play around with lambda expression and stuff like that. So I've done a version of this course internally at Bloomberg for like 11 or 12 times, and every time the feedback has been stellar, because I think I hit the right spot between, the speed which I teach staff, the interactivity, and the fact that people already know C++, so I don't have to explain every little detail. And I'm really excited to do this at CppCon. I think that even though, it's 2019, there's still people that have been working C++3 either for reasons regarding legacy architectures or because, they never had a need to move to 2014. And my intention is to capture all the different use cases, show people how these features can make your code better with real examples and make them play around with it. Because I think if it's just a lecture, if there's no interactivity, it won't be as stuck in their mind as it would be otherwise. So I hope that will be very well received, and I think there's still spots left. So if you're interested in that, or if you know anybody that hasn't had enough exposure to the new standards, that would be a good thing to suggest.
I got to ask a question about function ref,
Sure.
if you don't mind backtracking to that just a second. Does it ever dynamically allocate?
No, absolutely not. It's always the size of 2 pointers.
Always the size of 2 pointers. So I need to come to your talk to understand how you can do type erasure and never have dynamic allocations.
Yep. I will welcome you to my talk, but the gist of it is this thing never owns the function. It only refers to an existing one. So the caveat is that you have to be careful with the lifetime of the thing you pass into function ref.
Certainly.
As it will not extend it. But the only type erasure is the type erasure of the : operator call. So nothing else. I'm going to show you how it's done. It's actually quite simple and it's easy to implement. But there are some, as I mentioned, edge cases and decisions you have to make in the design process, as unfortunately there is no design or memory layout of this thing that will please everybody.
Yeah. Okay. That sounds tricky to get right.
Yeah, it is.
All right, cool.
Okay. Well, is there anything else you wanted to go over before we let you go today, Vittorio? Talked about a lot.
Yeah, I talked about a lot. I would not really anything in particular. I just want to say that the Epochs effort and even things like function ref, they're really driven by feedback and by what people want and need. So I really appreciated the reception to what I've done so far. And if anybody's listening to this cast and they have ideas or feedback, whether positive or negative, on any of these initiatives, I just think it's important to get it out early and, without being scared of saying it, even if it might destroy the proposals. I appreciate that, and I think it's important. So just, an encouragement for people and listeners to participate, not just in my initiatives and my efforts, but in general, try to be active into things they care about. And people writing proposals, people going to the meetings, they're always open to feedback from anybody. I can just find their emails or just find, their LinkedIns, whatever. They appreciate that. So please do that. It's good.
Yeah, it does sound very important that if someone says, no, it's absolutely impossible for Epochs to work with modules because of X, you want to know that information yesterday.
Yes, exactly.
Okay.
There's one thing I think I remember from the blog post I don't think we discussed at all, and you do want part of this to be providing some way to migrate from one epoch to the next, right?
Oh,
so
yeah.
A library should opt in, I want to be a 23 epoch. That's something that you want to be able to script them to help do as part of this?
Yeah. So this is actually another thing that Rust tries to do. What they do is their compiler has a fixed flag or something like that. I can't remember the exact name of the flag, but it can do most of the transformations from one epoch to the other automatically. The things that I mentioned, a dyn keyword, is basically just, find all the places this is a polymorphic reference and just stick the keyword there. Sure. So all of these changes are quite possible. And actually, if you've used the amazing CPP Insights tool by Andres Vertig, I think the name is, that shows you all the implicit conversions. So we already have the technology to change the implicit conversion to explicit ones by adding the cast in the right places. So all of these things are possible, and I think it would be a lot easier for people to migrate from one epoch to the other if most, if not and all of the changes will be automated. And the scope of the changes I have in mind, they should definitely be possible to be automated. And maybe that's also a good design guideline, like try to do things that could be automated. And if you go outside of that, then maybe think again whether that's positive change or not between epochs.
Okay, makes sense. Okay, well, it's been great having you on the show today, Vittorio.
Thank you so much for having me. Likewise, it's been good, I guess, like many years ago.
Yeah, thanks for coming on.